Welcome to Abhijeet Codes. So I hope you have watched the previous videos of structures and pointers in C++. And if you not watched them, please go and watch them because they will be very helpful in understanding this lecture. So in this lecture, we're going to see how the linked lists are created and what they are actually representing. So a list is generally represented like this. So we have few nodes. So these are all each individual nodes. They're connected to each other via these links. And this is nothing but a pointer pointing to next node. And each of the nodes have the separate locations in memory. And the last node will be pointing to a null pointer. Okay. The first node is generally termed as the head node. Now let's see what a node is. So a node is nothing, it is but a simple structure. So in the last video we have seen what a structure is. Here we are two variables, data, and another variable is of the same type but a pointer, and we call it generally next. So this is a node. And now as we have defined this a node can be used as a data type. So inside this node only we have a pointer next which points to the base address of another node. Suppose this is another node and its base address to be 1000. So in the next we will store the base address of this node. Thus these two nodes are now linked, and when several such nodes are linked we create a linked list. Okay, so that's hence the name linked list. So first node is connected to second, second is connected to third, third is connected to fourth, and so on. And the last node is pointing to a null. Okay. So for now you don't need to think of this very hard. You just need to listen what they are and go on with them. So now let's see how to implement the basic node. Okay. So in the node, as you already know, we declare a structure, the name of the node. This can be anything, but we generally write node. You can also use any other name. And inside this structure, we have got two variables. One is named data, and another is a pointer variable, which points to the data of same type, as we already seen. We can also give some default constructor for this. So default constructor will have data initialized to 0 and next initialized to null. We can also have parameterized constructor in this, and there we will initialize the data with data. Now as we are using the same names, you see this data is exactly the same as the data we have initialized here. Okay, so this data and this data are same, but they are different. They're not actually same. This data is the value which will be received via the initialization, and this data is the data of this local variable. So to access this data above one, we use the this operator. So this arrow data will be representing the data of this current structure. Okay, and next there is only one next, so we don't need to use anything else. Although we can write this arrow next here also. Next, so this is how we define a node. As we have already seen, a node has only two variables, data and next, and we can also provide some initial values to them. It is not compulsory to give the values, but we can use the constructors to simplify our codes for later. Now here we write the main function, and in the main function we first create a variable head of type node. So what this line will do, this will create a simple variable, and this is called head. Okay, it will have two variables. It is of type structure, of type node here, and we have declared that node has two variables, head and next pointer. So now we are accessing the data variable inside this head. So we're changing the value of this data to 5. The next will be initialized null because we are passing no values. So the default constructor will be used and this will be null initially. Then we create another node, we call it temp. So we create another node and we name it temp. We change its data to 10 and the next will obviously be null. Now what we'll do, we'll do head dot next. So the next of this will store the base address of this temp. So suppose the base address of temp is 4000. So now this 4000 will be stored here. So it will store 4000. And now we can print the data of our linked list. So we can write head data. So head data will be similarly 5. And now we need to move our pointer to the temp. So how we can reach temp? First we'll do head next because the head next has the address 4000. Now what we do, we use the dereference here. So we reach this address. Okay, so now we have reached temp, and in temp what we need to do, so temp is not this whole chunk, this both variables as a single chunk is temp. So inside the temp we need to access the data. There are 2 points, data and next, so we are accessing data here. So thus we will get hold of this 10. So this might be looking very complex to you. For to simplify that, we use another type of declarations. So we use a pointer. So how this works is, suppose we are creating a new node. Okay. So this line will create a new node with value 5 and next initialized as null. Okay. Now we are making a pointer of type head. So this is a separate variable and a pointer is pointing head here. So head will store the base address of this. So suppose this base address is 2000. So head will simply store 2000. Okay, in head we have just now only 2000, the base address of the node. And now we see this arrow operator. So what does this do? It goes to the base address and we have now got the hold of this, whatever this, suppose this was temp. So we have now got hold of this, and then we can access its variables, data with this and next with this. So head arrow next does the same thing. Okay, so what we do head dot next. That means this pointer's next variable will be equal to what? So head is pointing here and its next will be what? A new node will be created with this, and it will have 20 as value, next as null. Now let's suppose the base address will be 4000. Heads next will now store value 4000. Okay, now we are again going to head next here, and what we are showing there, we are showing there the base address of another variable. Okay, so let's create one more variable. The value will be 45, the initial value will be null, and we are, let's call it 6000 base address. So now 6000 will be stored here. So now if you want to move, we can simply go head data, then head next data. So head data will be simply 5. Head is here. Head data will be 5. Heads next is 4000. We reached here. And now we are doing data. So we get 20. Then we do head next, next, and data. So this will move to here and here and here. And what's its data is? Its data is 45. So this is a simple way to create a linked list. But if we go on like this, it might get very difficult if the size of the linked list increases. For suppose at each step we are using head next, 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 next. So this can go very lengthy. So in the next video, we will see how to create a simple version of linked list by inserting the nodes in the beginning, then inserting nodes in the end, or inserting the nodes at a particular position. So from the next video, we will see how to insert a node at the beginning of a linked list. So thank you. See you in the next video.